Hello, let us continue our discussion on fragments. In last lecture, we discussed what fragments are. Normally, you should assume fragment as a subactivity, which an activity can call. So that is, an activity can call multiple fragments, put the layout of the fragments in the activities view group. So you can see multiple fragments inside a single activity, and you can create dynamic and multi-pane UI that you may need if you want to develop your applications for devices such as tablets which have a large screen size, as well as for phones which have small screen size. So today we will learn a little bit more about fragment. So when you are doing fragment development, you can extend fragment from three important subclasses. These subclasses are dialog fragment, list fragment, and preference fragment. Later on, we will learn a lot more about dialog and what are the other ways to handle dialogs. But dialog fragment gives us a fragment which can act as a dialog. We will see later in the program how to do that. Similarly, list fragment shows us a list of items, and the preference fragment shows us a list of items in a priority order. Or the most general way is to just implement directly from the fragment class and then implement the functionality that you want to implement. Now, how do we create a fragment? Well, for creating a fragment, we extend the fragment class and we override the keys lifecycle methods. One method which we definitely use is the onCreateView method. When you create a fragment contributes its own layout to the activity. So you implement the onCreateView callback method, you return a view, the view that contains the layout of the fragment, and that layout is then inserted into the placeholder inside the activity. In order to do that, the fragment provides you a layout inflator object. And this inflate method takes three arguments. Let's first have a look at the method and then come back. So here's an example of the layout inflator. So yes, you can see that I am having a class which is extending a fragment. Inside that, the only method I am overriding is the onCreateView layout inflator. This method is taking three parameters. One is the layout inflator, another is a view group, and third is a bundle. The bundle is same as the bundle that we have earlier in our activity. The view group is also same as we know already. The interesting new element is this layout inflator. And the layout inflator actually calls a method called inflate, which again takes three parameters. And these parameters are what we are interested in. So let's go back. First argument is the resource ID of the layout. So this is the resource ID, as you see, r.layout.example fragment. This is the resource layout of the example fragment. So this is the ID of this. The second argument is the view group, which will be the parent of this inflated layout. So this will be set fit into this container. This container information will most likely come from the activity class, that is the parent class of this fragment. By parent class I mean the activity class that is using this fragment. And the third is an argument which is a boolean, which indicates whether the inflated layout should be attached to the view group or not. So we will set its value to false correctly. You may want to experiment by setting a true value and see how does your application look like. Now, we know how to initialize a fragment, how to create a fragment, that is extending the right class and then implementing the onCreateView method. Now let us see that how do we add a fragment to an activity. So There are two ways to add a fragment to an activity, and as you may also guess that the one way is to add it in the XML file itself, and the another way is to add it through the code. If you remember, in the very beginning we had talked about that for each activity we have a layout XML file, but we had also said that at that time that we can create all this using the code. With Fragment it is the same thing. We can either add a fragment inside the activities layout file, or we can programmatically add the fragment to an existing view group using the code. What do you think is a better approach, and in what condition? Think about it. So as you may imagine, if your fragment is not going to be too dynamic, then maybe you will consider the first approach where you directly attach it into the layout. However, if your program is such that you move fragments, you change between different fragments, then the second approach is more suitable. We will learn both of the approaches in next few lectures. Now, let us look at the first approach for the time being. How do we do it? Number one, specify layout properties for the fragment as if it was just another view. So now we already know how to add a view. For example, we added buttons in our previous example, which were a view. So the same thing, that we have to specify layout properties for fragment as if it were a view. Now let us see an example. So this is the example that is given here. Let me try to increase it so that you can read more clearly. You see that we start with a linear layout. This is the layout of the activity, and this activity contains two fragments which starts with the name fragment. So the value of fragment is only from this fragment till this endpoint. Now just like another view, it has the elements like weight, width, height, etc. But it also has something else. We have seen ID, weight, width, height earlier, but it also has something called Android name, and that name is actually giving what looks like a path to a class file. And actually this is what it is. From the name, the Android system will find out the fragment that you are talking about. It will inflate the layout of that fragment, and with these properties it will place that layout inside this view group. So let me come back again. A fragment has Android name, which will refer to the class file of the fragment that you are referring to. From that, and with these properties, the Android system will decide how to put the fragment as a view into the view group of the activity. So in this class, if you see, this is a linear layout, and in this class there are two fragments, and these two fragments. So most likely this is an interface for, I would say, a tablet where the screen is divided into two parts, something which we discussed earlier. Now one of the fragment may be displaying a list, it looks like by the name, while the another fragment may be displaying details of a particular item in the list. Now let's go back. So here is what we have discussed. The Android name attributes specify the fragment class to instantiate in the layout. So in our previous example, if we go few slides back, we were giving the example of this example fragment, and then we were saying that the example fragment will have inflate a layout here. Now if I had used example fragment here, then Android system will see, okay, it is example fragment, will go inflate the layout and put it into the view group of the activity. That is how it works. Now each fragment that you add requires a unique identifier that the system can use. As you will see that because we are using our fragments dynamically in the program, we need an identifier to refer to them. And the same identifier we use to capture the fragment to perform transactions, for example, removing it. Now, there are three ways to provide an identifier to a fragment. The first method is to supply an attribute called Android:ID. As you can see in this example, we are using this. This is Android:ID. Again, I will enlarge Android:ID. And then the second way is to supply the Android tag attribute with a unique string. We are not doing that because we are using ID. You can use either of it. And then the third is that if we don't do ID or tag, then Android system can always use the ID of the container. But I will advise you to use either ID or tag to identify your fragment in your program. Now that completes our discussion on how to add a fragment in the XML file of the activity layout. Now let's move on to the second way of adding a fragment, that is programmatically adding a fragment in our activity. So if we want to add programmatically our fragment, then at any time while our activity is running. So earlier, if you remember, we had just discussed that activity after the onResume method is considered in the state of running. So in that state, we can add fragments to our activity. What we need to do is we will simply have to specify the view group in which to place the fragment. So the requirements of specifying the view group is same. In the XML method, we were directly adding it into the view group. Here we need to specify the view group. Now let us look at the code that is given here. We obtain a fragment manager, we obtain a fragment transaction. Then this is our fragment, example fragment. We create the object of it. Then using our fragment transaction, we add our fragment to the view group where we want to add. So this is the view group r.id.fragment_container. If we go back, then we will find this container in this. So this is the value that will be supplied. So here it is coming out here. So this is the container of the activity. So this is the view group in which we are adding our own fragment. And once we have done it, we do a commit. So all this is called a complete fragment transaction. And for doing these transactions, we use the APIs from the fragment transaction. So think of the transaction of fragments similar to the transactions that you have learned in database, where you do a series of operations which you call as a transaction. And after each transaction, you do a commit. Same thing here, we do a series of operations and then we commit. Now let us come next on discussing how to manage our fragments. So we can manage our fragments using the fragment manager. This is the same fragment manager that we are talking about. In the fragment manager, first we will have to obtain a reference to our fragment, and that reference we can find by either using find fragment by ID or find fragment by tag. So this will return us the fragment that exists in our activity. Now earlier we had discussed about backstack, which was something maintained by the activity to manage your fragment transactions. So the pop backstack method will pop the latest transactions from the stack. And we can also add a listener to it. This is called add-on backstack change listener. So if there is a change in the backstack, then this listener method will be called. Now let's move forward and learn about how do we perform fragment transactions. So each transaction, as you know from your database knowledge, is a set of changes that you want to perform at the same time. You can set up all the changes you want to perform for a given transaction using methods such as add, remove, and replace. And then to apply the transactions to the activity, you must call commit. However, if you want to add the transaction to the backstack, then you may also want to call a method called add to backstack before you call commit. This backstack, as told to you earlier, is managed by the activity and allows the user to return to the previous fragment state by pressing the back. Few more details. When you call commit, the action does not perform immediately. What commit does is that it is scheduled to run on activities UI thread, which is the main thread. And then it leaves it to that thread. And as soon as that thread is able to do the commit, it does the commit. That is that all the transactions which we mention in the commit will be executed. But it depends on the activities UI thread. However, if we want to do an immediate execution, then we call execute pending transactions from UI thread, which then immediately executes transactions submitted by commit. Another important detail is that a transaction can be committed using commit only prior to the activity saving its state. That is when the user leaves the activity. If you remember when we were discussing activity and fragment and we were discussing their methods like on pause, on stop, on destroy, at times we were talking about committing the transactions. So this is the point here. So we can only commit only prior to activity saving its state. If a commit after that point, an exception is thrown. Now let us look at some code that performs the fragment transaction. So here is an example code. First you create your new fragment, then you create a new transaction which will get a fragment manager and start the transaction. The transaction that you are doing is actually replacing the existing fragment at this fragment container with our new fragment, and we are doing this replacement using the call replace. Earlier you had seen the call to add. There is also similar call to remove. We want this transaction to be available on the backstack, so we are doing a transaction.add to backstack before we do the commit. So far we have talked about fragments which have a UI, but a fragment could also be there without a UI. Now you may want to wonder that what is the use of a fragment without a UI? Well, one simple example is if you want to do something in the background. So there you can have a fragment which doesn't have a UI. Now let us see that how do we add a fragment without a UI. It is again very easy. We can use the same add. So here we are giving a string and not a view ID. It will add the fragment but will not call on create view because we need not to create a UI. And then find fragment by tag will return the fragment. So here we have learned that how to do basic functionality within the fragments, how to perform transactions, how to add a fragment, etc. Now let's come to the another very important topic, that how do the fragment communicates with an activity. So let's see. First, a small recall, as I told earlier, that fragment can be used inside multiple activities. And in fact, you are advised to develop a fragment so that it is an independent module which can be used inside multiple activities. But a given instance of a fragment is directly tied to the activity that contains it. So while there could be multiple activities in your application, the activity that contains the fragment at a given point of time, your fragment is directly tied to that activity. So how does the fragment gets the reference of the activity? Well, there is a call called get activity. When a fragment makes a call to get activity, it gets a reference of the activity instance in which it is currently running. So by doing this, then it can do other perform tasks. For example, a fragment in this example, your fragment wants to get a view in the activity layout. So it makes a call to get activity. Using that reference, it calls find view by ID. Just like fragment can access activity, activity can also access fragments. So the activity can call methods in the fragment by acquiring a reference to the fragment. How does activity gets a reference? By calling this method called get fragment manager and find fragment by ID. So now my activity has got a reference to the fragment. So you see that both activity can get a reference to the fragment and fragment can get an activity. It can get a reference to the activity. Now, let us discuss about how to have callbacks which also allow the interaction between a fragment and an activity. So we use callback to share some events with the activity. How do we do it? Define a callback interface inside the fragment and ask the activity to implement that interface. Now, when the activity receives the callback through the interface, it can share the information with other fragments in the layout as necessary. So let's quickly look into a very brief example. Again, let me increase the font. Here you see that there is a fragment and this is the interface. Now let's go to second screen. Here we are doing little bit more than that. So earlier we had this on article selected listener. Now you can see that it is coming here, going to M listener, and then in the third screen you can see that from the M listener we are actually doing it. So later on we will run a program and where we will see that how to implement a callback. But this gives you a basic idea, which was you define a callback interface and you require the host activity to implement it. In later videos we will write a program which is actually doing it. Now let us discuss a little bit more about the fragment lifecycle. We discussed it briefly in the previous lecture. In this lecture we are going to discuss it in more detail. Number one, let us see how does the fragment lifecycle and activity lifecycle work together. So let me also make the bigger image so that you can see clearly. On the left side I am mentioning activity states and on the right side I am mentioning fragment callbacks. So when the activity state is created, that is the very first activity state, the fragment callbacks, 4 fragment callbacks happen at the same time. On attach, on create view and on activity created. When the activity state moves to started, on start callback happens. When the activity state moves to resumed, on resume callback happens. And as you know from your knowledge of activity, that the activity stays in a longer duration only in the resumed state and not in the created and the started state. So this is the major state in which an activity is, and fragment callback is the on resume. Then in paused and stopped also an activity stays for a longer time, and that also results into the corresponding calls in the fragment. But when an activity is destroyed, this again requires a multiple number of callbacks to be called in the fragments on destroy view, on destroy and on detach. What my advice to you is to override all these methods in your fragment example and put appropriate log messages there. similar to what we did when we wanted to understand the activity lifecycle. Now once you have placed the log messages, then you run your program and you do various things. You press the back button, you press the home button, you start another application and try to see that what is happening to your fragments when your activity is changing its life cycle stages. Let's come back to the normal font, move to the next slide. So let's go again into the resumed, paused and stopped, because these are the three major states in which activity also lives for longer time and fragment also. So in the resumed state, the fragment is visible. In the paused state, there is another activity in the foreground and has focus, but the activity in which this fragment lives is still visible, something like a dialog box coming up, right? And then in the stopped state, the fragment is not visible. Either the host activity has been stopped or the fragment has been removed from the activity. Just like the activity, a stopped fragment is still alive and it is just no longer visible. So as you see that there are lots of similarities between fragments and activities, and if you understand the activity, you should have little problem in understanding the fragment. Now let's discuss the life cycle a bit more. Just like what we did in our activity, we can also do in fragment. That is, we can save the state during the fragment's on save instance state callback and restore it during the on create or on create view or on activity created. This functionality is also very simple as we did in the activity using the bundle. So effectively, a fragment lifecycle is very similar to the activity lifecycle. Now let us see that how these two life cycles coordinate. So the life cycle of activity in which the fragment lives directly affects the life cycle of the fragment. So activity life cycle is controlled by, let's say, Android system, and fragment life cycle is pretty much controlled by activity. Each life cycle callback for the activity results in a similar callback for each fragment. So if in a life cycle on resumed is called, then in the fragment on resumed will be called. The fragment has some few extra lifecycle callbacks that will handle the unique interaction with the activity in order to perform some actions. For example, building and destroying fragments UI. So again, some details. What happens when the methods other than what is exactly common with the activity happen? So when on attach is called, when the fragment has been associated with the activity. On create view is called to create the view hierarchy associated with the fragment that we have already seen. And on activity created is called when the activities on create method has returned. Similarly, on destroy view is called when the view hierarchy associated with the fragment is being removed. And on detach is called when the fragment is being disassociated from the activity. The best way to learn about all this is to write a program, override the methods, add the log messages, and then play with the program to see what is happening. So one more time, I will display the same image that I displayed earlier. You can see on attach, on create view, on activity created, which we just discussed. Rest of the methods are same. Then on destroy view and on detach that we just discussed. So with this, we complete our discussion on fragments, and in next lecture we will work through a programming example to see some of these concepts in action. Thank you.